All right, folks, it's time for your final video lesson before the Advanced Placement Calculus exam. Start! It's time to have some fun, all right? Look, this is Monday, okay? Hopefully you got a good amount of work done over the weekend. I know it's a lot of problems I sent out, but I want you guys to be prepared, not just for the AP exam, but also for math classes in the future, okay? That's what it's about. The AP just released, actually, I'm making this video on Friday. Just realized they released a little sample of your 2020 AP. Nothing crazy, okay? It's only one question that kind of mimics what the 25-minute question would be like, because obviously that's a little bit bigger than some of the free response questions that we do. I'm attaching that, okay, posting it to the website, okay? So tonight for homework, you could try to finish up this ditto right here, which is free response practice 5.6, I believe. And also, try that practice AP, okay? You know, they give you a little practice problem. It's the 25-minute problem. 5 minutes to submit your work. So, take a look at something like that, all right? Actually try it out. It's really just pieces of a 2019 problem that we may or may not have done. I don't remember, okay? But for the most part, it's just modified slightly. But take a look at it, try it out. They didn't give you a sample for number 2 because the second problem is just supposed to be a 15-minute problem that is very similar to all the free responses that we've done. Okay, so be on the lookout for something like that. But they did say it would be similar possibly to 2 questions that were given last year. One was a differential equation. One was an interesting miscellaneous type of problem that we did a little bit earlier in the AP review. So I attached those as well. Okay, so make sure you take a look at that 2020 sampler. Finish this up as well. Make sure you get sleep tonight, okay, before that AP exam. It's going to be 2 p.m. tomorrow, okay? Make sure you eat something. I wouldn't say engorge yourself on like a huge Italian hero, 5 minutes before the exam, because then you might be like, blah, blah, how am I going to do these problems? But, make sure you eat something earlier in the day, okay? Make sure that you have your wits about you, okay? That you're rested, that you're fed. Make sure you log in to your e-ticket 30 minutes before the exam, okay? If you didn't get an e-ticket, you're supposed to be able to log into My AP and it's there, okay? They said you'll get it 2 days before the exam. What does that mean? Does that mean that you got it on Friday because that's 2 business days before the exam? Or did you get it yesterday on Sunday, which is technically 2 days before the exam? That's probably what happened. If you didn't get that email, let me know. Text me and remind, but you should have already set up contact information with the College Board. Check your junk mail folder if you want to. And like I said, you could still log into My AP. Make sure you do so at 1:30 p.m. tomorrow. Don't mess around, okay? Get in there a half hour early. You're going to have to input your personal information. I hope you already practiced uploading answers. Probably the best way to do it would be to, look at the problem on a laptop or a desktop and then, take the pictures of the answers with your phone and either email them to yourself or use Google, Drive. If you're using your phone, that's fine, okay? But just be careful. It's not going to be so easy to zoom in and see what's happening on every question. So do the best you can, of course. If you're using a newer iPhone to take pictures, it's not a compatible format. That's an HEIC format. You can go into your phone. There are directions on my website. You could change it to the most compatible. So that'll all be taken care of. If you just read my website, if you try the demo on your own, look at that video I posted of that teacher, uploading responses. At that time, we thought PDFs were no good, but you can actually upload your answers in PDF form if you're using like Cam Scanner or like TurboScan, one of those apps. Just a PDF can have multiple pages, and you're not going to attach photos. You're going to select attach text, okay, for a PDF, because technically it's a text file, and then you're just going to submit one PDF for each question, okay, because your PDF could have multiple pages. If you're taking pictures, you could submit multiple photos for each question. Just make sure you don't hit submit until you have them all uploaded. If you practice on the demo, once again, you should be good to go. And did I have one final thing on that? No, I don't think so. Okay, taking pictures, that format right there, PDF. I think that's all I wanted to say. So once again, hope that you're putting your work in. The first page of this ditto right here has just 2 problems that are part 1 problems, really. This one right here, I doubt you'll see something like it on the AP, but it did show up many years ago, and it was a difficult type of problem, and it showed up on a practice AP, I don't know, 5-6 years ago, something like that. So who knows, there could be something like this somewhere on your test. So let's do this problem real quick. And really, it's a problem that deals with shadows. All right, so we have a person who's not me, because the height is 6 feet, walking away from the base of a street light at a straight path at a rate of 4 feet per second. If the height of the street light is 15 feet, what is the rate at which the person's shadow is lengthening? So hopefully you realize that this is a related rate problem. They actually tell you that, the person's 6 feet in height, but they tell you walking away from the street light at a straight path at a rate of 4 feet per second. So they gave us a rate right there. And then they actually want to know a rate, right? The rate at which the person's shadow is lengthening. And they do give an instantaneous moment. Well, not really. They tell you the height of the street light is 15 feet. They tell you the height of the person is 6 feet. Okay, so right here, I know the height of this person. I'm just going to draw all over the person. Sorry, buddy. I know that's 6 feet right there. I know this height is 15 feet. And whenever they talk about a shadows problem, okay, on the AP, that's a related rate. Think about similar triangles, okay? And people are like, similar triangles, what are you talking about? Well, if you actually draw this right here, you actually have two triangles, okay? You have the big right triangle and you have a smaller right triangle right here. So you got your big right triangle and then you have your smaller right triangle right here. We know this length is 6. We know this length is 15, okay? They gave us some things. They told us the rate at which the person's walking away from the base of a street light along a straight path at a rate of 4 feet per second. That's the rate at which this distance is changing right here. So that distance would be x right there. Okay, so that's the distance between the person and the base of the street light. So they give you the rate at which he's walking. So that's dx over dt. So is that 4 feet per second? Okay, that's what they tell you right there. They want to know the rate at which the person's shadow is lengthening. Okay, and here's the shadow right here. They draw it for you. I'll call it y because we know that's changing. So we want dy over dt. That's what we're looking for, okay? And look, these two triangles are going to be similar. I don't know if you remember the angle-angle postulate. Of course you do, right? Two similar triangles. They both have this right angle, and they both share this angle right here. So we know these triangles are actually similar because of angle-angle. Corresponding sides of similar triangles are in proportion. You want an equation, okay, that relates x to y. Well, remember, this distance right here would be y. This distance right here wouldn't be x. It'd actually be x plus y. And now we could actually set up a proportion. There are many different proportions. You could say 15 over 6 equals x plus y over y. Don't cancel the y's. I'll say 15 over x plus y equals 6 over y. That's a nice one. So 15 over the quantity x plus y equals 6 over y. Look, you could take the derivative right now if you want it to be a complete disaster, but if you cross multiply and get 15y equal to 6x plus 6y, so much easier now to differentiate implicitly with respect to t. Okay, here we get 15 dy over dt is equal to 6 dx over dt plus 6 dy over dt. Remember, the dy over dt is what I want, so if I actually subtract 6 dy over dt from both sides, I get 9 dy over dt is equal to 6 dx over dt. And now it's really just a matter of plugging in. It's a pretty simple problem. I know it's, dy over dt. Why am I writing that 9? Well, yeah, technically that 9's still there. Is equal to, we know that dx over dt is equal to 4. So really dy over dt is really just going to be 24 over 9 feet per second. Okay, putting a 9 into a 24... 9 goes into 24. I don't know. What's 9 times 3? 27, so that's not good. 9 times 2 is going to be 18. Subtract from 24. That gives us a 6. Put a 9 into a 60, and 9 times 6 is 54. Okay, so it actually leaves us with another 6 left over. Then you actually end up with 2.6 repeating. Truncated form, 2.667. Okay, it's actually rounded form, pardon me. It's a non-calculator problem, so it's kind of interesting that they have that there. Once again, nothing you have to worry about in the EP. If you get that, put it right in, and then you'll get your answer. I don't think you'll see this, okay, but it's there just in case. I do think you'll definitely see something like number 2. Maybe not exactly. If you look at the 22 AP practice, they do give you a limit. That's a quotient. A lot of times people think it's going to become L'Hopital's rule. This probably is on your AP exam, but the one in the 2020 practice doesn't, and there was one last year that didn't as well, even though there's one in another AP practice that did. This I want to talk about because what we usually do, and I'll cheat and show you my answer key. Usually you plug in top and bottom, and we say this is 0 over 0. I've mentioned this before on videos. I hope you've been looking at it. Okay, technically you're not supposed to say it equals 0 over 0, which I've mentioned many times, so stop yelling at me and silently cursing me out there. If it's a part 1, that doesn't matter. Usually I put an arrow and put 0 over 0. They're not enthralled with the arrow either. What they really want is for you to look at this and be like, hey, this becomes, when you plug in e squared plus 1 minus e squared minus 1. So this whole thing right here is going to tend to 0. That's the way they want you to show that. We've shown that with certain things before. Put that little arrow, which is looking more and more like something that's not an arrow as I try to fix it. I guess that's okay. Look at how big the arrow is now and how small the 0 is. It's messing with my OCD. Okay, so I know that this tends to 0 right here. And the sign of 1 minus 1 is really the sign of 0. I know this tends to 0 as well. That's what they want you to write, okay? So don't lose points because of notation on this AP. If you end up with a limit of a quotient, plug in top and bottom. You know, if you get numbers, just put equals number over number. Nothing wrong with that. You'll see that in the 2020 AP practice. But if you get 0 top and bottom, put a little arrow to 0 to the top, 0 to the bottom. And that means you could use L'Hopital's rule. So now we can say the limit as x approaches 1. Take the derivative up top. What's the derivative of e to the 2x? That's 2e to the 2x. Better be able to do that easily by now. Plus the derivative of x is 1. Minus 0 minus 0. This is just a constant e squared and 1 right there. So the derivatives are just equal to 0. The derivative sign is going to be cosine. Rewrite the inside. Don't forget to multiply by the derivative of the inside. Even though if you do that here, you're still all right. Okay, and now we could reevaluate the limit. 2e to the 2 times 1 plus 1 over cosine of the quantity 1 minus 1, which is great because that's the cosine of 0, which is 1. Geez, technically, you know what? In a part 2, you could leave it this way. You wouldn't be wrong, okay? But you do want to make sure the bottom and the top doesn't tend to 0 again, because then you got to use L'Hopital again. This becomes 1, so you don't have to worry about it. And this is just 2 e squared plus 1. So really, 2e squared plus 1 is the answer we're looking for there, okay? So look, I'm sure it's going to show up somewhere in a part 2, whether it's a limit of a quotient that becomes 0 over 0 and you need to L'Hopital rule, or just limit of a quotient where you get an answer. All right, so be on the lookout for that. I really feel like one of your problems is going to be a differential equation problem, okay? And I'm thinking if you look at the 2020 they released, I really feel like one problem is going to be abstract and one's going to be applied. You know, the problem they released, the 25-minute problem, that's abstract right there. One of the problems they asked you to look at for 2019 was a differential equation problem that's applied. I really feel like you might have an applied differential equation problem for your second question. I hope you looked at that. Okay, we did a 2011 problem, the differential equations packet. That was a landfill problem. You had a homework problem with 2012. It was a baby bird problem. And you had that potato cooking in an oven problem that I gave you for a take-home, okay? Whether you just copied your answers from somebody, at least you wrote it down. Take a look at that. I really feel like you're going to have one like that in this AP. Maybe it'll be abstract. Maybe it'll all be abstract, okay? But differential equations, great type of problem because it really encompasses a lot of pieces of the curriculum. I think you're going to have one. So let's go do this one right here. Let f of 2 equal -8 such that for all points x comma y in the graph of f, the slope is given by this guy right here. So they give you the slope. They're telling you that dy over dx equals that. Just because they said the slope is given by that, didn't write dy over dx equals. Come on, you should be able to handle that. They tell you later on, by the way, what dy over dx is equal to. So sometimes they give you hints, you know, a little bit further in a problem. Make sure you read a problem, okay? Everything they tell you, okay? I was talking to Pushy. He tutors a lot of AP calculus. And one problem he actually couldn't answer because he didn't just read a sentence that's actually there. So sorry to call out Mr. Pushy. I was normally going to say even somebody who's smart can make a mistake, but he wasn't a good example to use because he's an idiot. So basically what I'm just trying to say is that make sure you actually read these problems right here. Sorry about that. No, I'm not sorry at all. Search your feelings. You know it to be true. So here they want you to write an equation of the line tangent to the graph of f at the point where x equals 2. Use it to approximate f of 1.8. We've seen a lot of this. I wouldn't be surprised if that showed up on your AP exam. It's pretty popular. Sometimes they want to know if the approximation, the linear approximation, is an under approximation or an over approximation. Then you're thinking about concavity. We did that earlier in AP review. Make sure you're prepared. But they said write an equation for the line tangent to the graph of f. So f is my original function, my OG function here, at the point where x is equal to 2. And remember, you could use that as a decent approximation to the graph of f as long as you're at an x coordinate that's close to 2. 1.8, pretty close to 2 right there, okay? So as far as part A is concerned, equation of tangent, if you can't do equation of the tangent line, just get out of my life at this point in time, okay? First, we need the slope of the tangent line. The slope of the tangent line, take the derivative. People are like, I don't know the derivative. They told you the slope is given by this right here, for crying out loud. We know that dy over dx is equal to 3x squared over y. We really want to evaluate that when x equals 2. People all lose their mind. They're like, when x is equal to 2, I don't know what y is equal to. Come on, folks. They told you y was equal to negative 8. A niche can dish right here. So really you're just evaluating the derivative of 2 comma negative 8. So what is that? 3 times 2 squared divided by negative 8. So 3 times 4 is 12 divided by negative 8. So you could say negative 12 eighths. You could divide by 4 top and bottom and say negative 3 halves. Probably the nicer way to do it. Once again, you could just circle this. That's fine, okay? But you're going to have to plug into this later, even though it won't matter because you don't have to simplify it anyway. So maybe it should be simpler to do that. But you have your calculator next to you for this AP exam as well, even though you explicitly won't need it. Now let's actually get what b is. Plug in a y equals mx plus b. Replace everything with the b. So we know that m is negative 3 halves. We know x is 2. Y is negative 8. You know, don't get me wrong. You could just write b as negative 8, plus 3 halves times 2 if you want to. Sometimes not simplifying starts to become a little bit more of a ruckus than simplifying. Here just add 3 to both sides. B is negative 5. Therefore, even though there are 3 dots, we got y equals negative 3 halves x minus 5. Okay, right there. And that means if you want to approximate, what was it? F of 1.8. It's approximately negative 3 halves times 1.8 minus 5. And bam, I'm just going to leave it right there, okay? And there's nothing wrong with that. I mean, like I said, you could really be crazy and say f of 1.8, let's see how this goes, is approximately, instead of getting negative 3 halves, maybe you left it as 3 times 2 squared over negative 8, right? That was my slope for before. Then you do the 1.8. And then for the y-intercept, okay, if you just had negative 3 halves times 2, subtract, this is going to get really ridiculous, okay, plus the y-intercept, which is negative 8 minus, okay, that negative 3 halves times 2. So I guess it would look a little something like this. Is this right? Is this wrong? Let's see. So this right here would be 3. Negative 8 minus negative 3, really negative 8 plus 3, so that's my negative 5 right there. So technically you could say this as well, okay? But it just gets a little bit extra at this point. It's probably easier to go right there. So don't get too cray-cray, you know what a say. Part B, if they give you a differential equation in an AP question, usually you have to solve that differential equation later on. 99% of the time. I can think of one time out of like 100 problems where it didn't happen that way. Even straight up tell you, they might not, say, I think in the other problem, they said find the expression that represents the temperature of the potato. You need to realize that meant solving the differential equation. But if you see a differential equation, you don't know what to do, solve it somewhere on the paper, okay? Because it's usually worth a really good chunk of points, too, out of the 9 for a normal 15-minute question. It could be worth anywhere from 4 to 6 points. That's a spicy meatball. That's what we say in the land of American Italians. I am American Italian. Little Polish in there as well. That's where I get my funniness from. It's a great thing about this country, by the way. So many different people just hanging out together, having fun, like in a calculus classroom. So if you want to solve this differential equation, this is something we did with distance learning. I hope you put in your work. If you didn't, if you slacked off, you're feeling the pain right now. And I hope you're feeling that little pang of regret that you didn't do all that you could have done, okay? Because you could all do well in this AP exam. I believe in you all. I love you all. Trust me. Once again, if you had some crazy things going on, I understand that, okay? Life is more important. Hey, cross multiply. Always put the dy on the left-hand side. And after you cross multiply, you're not always separated right away, but here I am separated. I don't even need to move things around. Remember, you could clean up the left-hand side if it gets a little, filthy. So I'm set up to integrate right here. Integrate y to the first. Y squared over 2. Not necessary to put the plus c there. 3x squared, that's somebody's derivative in there. Whose derivative? X cubed's derivative, right? Don't forget to add the plus c right there. Once again, you could just say 3 times x cubed over 3. You'll get x cubed that way. You could leave this for your general solution. I like to clean up the left-hand side of constants when I can. So I'll multiply by 2 on both sides, and then I'll get y squared is equal to 2x cubed. Remember, 2 times a constant, just another constant. That's my general solution, sir, that I'll use. And remember, they want you to solve for y, right? Find an expression y equals f of x. If you don't solve for y, you say in trouble. But I don't solve for y with an advanced algebraic technique until I solve for c. And they told you that f of 2 was equal to negative 8. That means 2 comma negative 8 is a point on the function. You don't need to write that. We already know that. So y squared, so negative 8 quantity squared, equal to 2 times 2 cubed plus c. So a little annoying to solve here. What is that? 64 equals 2 times, what's 2 cubed? What what is it, 8? So 16 plus C. Okay, so over here, subtract 16 from both sides. 48 is equal to C. So make sure you use the general solution used to generate that particular value of C for your particular solution. So y squared equals 2x cubed plus 48. Then obviously here you want to take the square root of both sides. Now be careful because some people are just going to write this. That's a good place to start, but there are two square roots. It could be the positive square root or the negative square root. Remember, when you plug in a positive 2 here, you got to get a negative answer back. I already know that I'm not going to get a negative answer back unless I have a negative square root. A positive square root will not generate that. So basically, if you're supposed to get back a positive answer, positive square root. If you're supposed to get back a negative answer, negative square root, okay? You're only talking about losing 1 point if you don't indicate the negative, but look, that's a point you shouldn't lose, okay? So a differential equation problem that hopefully is really not too terrible for you, okay? I really think you're going to see one. I really hope, once again, you've been practicing uploading these things, and the day of the AP exam, you can just focus on calculus, not worry about uploading. If you have any problems with uploading, if things, don't work out, don't freak out. You could submit a petition to the College Board, and then they'll let you take the makeup exam, which is, I don't know, June 1st or something like that. After the AP exam, I will still be posting, questions, and then you could you still practice the part 2s, okay? And you got a whole lot of practice. But this is the time you want to take the AP. You're in the groove right now. You got to remain in the groove if you want to take the AP late, which means you want to keep doing practice problems that I post. Here we have a problem. It's not the next problem in 5.6, the packet that you printed out. It's the last problem because I changed some things around and I didn't want to reset up the entire, file again. So should be pretty easy to find. I changed something right here. Okay, you can see I wrote it. You can see the whiteout and stuff because I had it as one thing, an extra problem, I added, but then I wanted to change it up again. Should all be fine in your ditto anyway. You have the answers as well. So I really think there's a good chance you'll see an accumulation function problem. They're kind of pushing that, okay, for this AP exam. So good chance you can see something like this. The graph of differentiable function f on the closed interval -3 to 15 shown in the figure above. The graph of f has a horizontal tangent line at x equals 6, which they don't really need to tell you, but probably it's going to be involved somewhere in a piece of this problem. And they say let g of x equal this guy right here, which is a function that involves an accumulation function, okay? So whenever you do this, make sure on your paper that you got set up, you got your little lined paper. I'm going to say I always take the derivative right away, g prime of x equal. It's a little bit different here from the accumulation function with the 5 in front, but we did one on Friday that had like a 3x in front or 2x, something like that. We did one, then you had another one for homework. 2011 problem, I think. This one's a little bit easier. Take the derivative of 5, you get 0. Take the derivative of this accumulation function, drop the x in for the t, the integral sign goes away, the dt goes away. You still get g prime of x equals f of x, and I'll say g double prime of x equals f prime of x. We write that down on our paper so that it could help us do the problem, obviously, but also later on, you have to justify things in terms of f. If you accidentally justify in terms of g, this might actually, help you out a little bit, watching your back, but you still might not get the perfect amount of points. Anyway, as far as part A is concerned, I'll do part A over here, because I want to make sure we actually have enough room, okay? On the AP exam, the way it normally is they give you a testing sheet where they just, I think, give you a little box to do each of these questions right here. But even so, you're just going to be uploading big white pieces of paper, okay? Try not to use lined paper if you can, but regardless, have this written on there. It's part of the solution considered. G of 6, okay? G of 6 does not involve what we just did, okay? You plug it right in the accumulation function. 5 plus the integral now from 6 to 6 of f of t with respect to t. And this is the lusciousness right here, because we really know it's just 5 plus the number of friends that Mr. Pushy has. That would be 0. I'm going to circle 5 plus 0 right there. Come on, man. When the two, stick it to the squirrels. When the two bounds are tied that the integral is going to be equal to 0. Geez, I wonder what the area is from x equals 6 to x equals 6. It's nothing. Okay, then they want g prime of 6, which, believe it or not, is even more of a joke than what we just did, because g prime of 6 we now know is equal to f of 6. And if you can't get f of 6 given the graph of f, you're in trouble, especially if you could actually easily identify the y-coordinate that goes with the next coordinate of 6, which would be 3. Piece of cake there. Try to box in your answers. Try to be neat, okay? It's going to be easier for the AP exam scorers to know what's going on. You always want to try to make their lives easier. G double prime of 6, you might think is a little wiggity whack, but we know it's the same thing as f prime of 6. People are like, aren't given the graph of f prime. How am I supposed to get f prime of 6? I don't know. Use like one of the most fundamental and important concepts of calculus we've ever learned. This represents the slope of f at x equals 6, slope of the tangent line. Oh, they even told me it was a horizontal tangent line, which we know has a slope of 0. Pretty simple right there. I'd expect all you guys to do very well on those problems, that part A right there. Part B, now they want to know on what intervals is G decreasing. Also easy. Come on, G decreasing. You know, once again, you should be sitting up in your room taking this thing, or sitting on your car. Who knows where you are? Try not to be in your car. Yeah, G decreasing. Surely there must be some sort of test. And there is. Okay, the first derivative test on G. So I want the G prime line. Coincidentally enough, is the F line. And are you telling me I want to draw the line for the graph that I'm given? That's when I check above and below the x-axis, okay? Normally on the AP, you just have to think about that in your head. You can't scream that out in a room, you know, so you gotta be can't even make those noises. But now you can. I really want you to have fun taking this AP exam. Scream out stuff, hopefully not expletive words while you're taking the exam. I want to check above and below. -3 to -1, this thing is below. Then it's above until we get to 12. My mental age, and then it's below the rest of the way. Okay, so we just want to know where G is decreasing. So G decreasing on, we know it's -3 to -1, and also 12 up to 15. Because, okay, always justify that answer even if they don't tell you. Look, I know it's because G prime is negative, but remember, they want you to justify in terms of F. F is the same thing as G prime, so I'm going to say because F is negative. F less than 0, and even box it in. I don't always box them in on the solutions and stuff, but try to do that to make whoever's grading your AP's life a little bit easier. I'd mess this up from -3 to -1. Look, that's from -3 to 0, right? That this thing is below. Notice I looked over here and I saw the -1, so it's easy to make that mistake. Okay, so really this right here should have been a 0, which changes this to a 0. So my apologies for that. Okay, but you can see how easy it is for, to make a silly mistake like that on the AP. Just be careful. Do the best you can. You know, you'll probably make a silly mistake on something. Nothing wrong with that. By the way, if you said G prime less than 0, you'd be okay, because right here you're saying G prime is equal to F. But it won't work on part C. You know, part C, on what intervals now is the graph of F concave down? Honk down. I mean, we're talking about, surely there must be some sort of test, okay? And there is. This is the second derivative test of G. So I wish to draw the G double prime line, which we know is really the F prime line. You telling me I want to draw the line for the derivative of the graph that I'm given? That's when I check increasing, decreasing from -3 to 15 here. Check the slope, right? You know, slope is positive. This thing's increasing from -3 all the way to 6. And then decreasing from 6 all the way to 15. So really simple, G double prime line to draw right there. And we're going to say that G is honk. Let's write the word concave down. You can write those symbols too, but write the words for the AP exam if you can, if you have time. It'll make it easier for them to read. G concave down, we'll say on, and we know it's the interval 6 to 15 because, here, you can't get away with saying G double prime is negative. You know, if you say G double prime is negative, you might be like, yeah, but that's the same thing as F prime is negative because I have it written right here. This is not F prime, okay? They want to know what F prime being negative means about F. That means F is decreasing or F has a negative slope. Either of those would be fine. Look what's happening from 6 to 15. Just look what's happening in the graph. It's decreasing. Don't tell me it's negative. It's not always negative from 6 to 15, okay? So because F is decreasing. That's what they're looking for. And hopefully you could read what I just wrote. Okay, so, just be careful with stuff like that. Okay, that's essentially what they're looking for in that problem. It's not really too bad. We've done ones like that. Let's do D over here. And then we'll do part E over here. We should have the room. I wanted to do D because we've done a bunch of approximations, Riemann sum and trapezoidal. I think almost every one we've done so far has been subintervals indicated by the data in a table, something like that, where you had to get the area of each trapezoid separately or the area of each rectangle separately. You can always do that, by the way, even right here. But sometimes they say subintervals use of equal length, and they even tell you what it is here. Delta t is equal to 3. That means you can actually write an expansion out if you want to. So subintervals of equal length, if you want the integral from -3 to 15 of, f of t, with respect to t, approximately, okay, a trapezoidal approximation. Remember, if you actually do delta t, delta x, delta t, remember, it's always b minus a over n. So in this case, it would actually be 15 minus -3 divided by 6, which is really equal to 18 divided by 6, which is 3. And they told you delta t is equal to 3. They don't always tell you what it is. Sometimes you have to calculate it. But if it's 6 subintervals of equal length, and they might say equal length here, they say of length delta t equals 3, so essentially it's the same thing as equal length. You know, now you could do the expansion. Remember the expansion? Trapezoidal expansion always starts with 1/2 times your delta t or your delta x, whatever it might be. Okay, so this 1/2 is really just from the formula to get the area of a trapezoid, and this 3 right here is really your delta t. And it's going to start with f of the lower bound. In this case, it's f. It could be v in some problem, v of, you know, here it's f of -3. And I know it's going to end with f of 15, but in between, there's going to be a 2 in front of each f of. Okay, so 2 f of 0 would be the next one, right? Just add your delta t to get from one argument to another, plus 2 f of 3, add a delta t, plus 2 f of 6, add a delta t, plus, remember, the next f of is going to be 9 here, so I still need a 12 in front, it's not 15. So 2 in front, pardon me, it's not 15. 2 f of 9, plus 2 f of 12, but don't forget, for the last one, we're going to be up to f of 15. We don't need that 2 in front. Okay, so this is what they're looking for here. This is really 3/2. You can leave it as 1/2 times 3, not a big deal. Make sure you put in the values, right? F of -3 is -1, plus 2 times f of 0, 2 times 0 is 0, plus 2 times f of 3, 2 times 1 is 2, plus 2 times f of 6, 2 times 3 is 6, plus 2 times f of 9, 2 times 1 is 2, plus 2 times f of 12, 2 times 0 is 0, plus just f of 15, which is -1. So this is what they're looking for right here. I got the answer, you know, it's actually 12, okay, obviously, but that's what they want. No units here because it's an abstract problem. You could have done what we've been doing. Just think about the first trapezoid, okay, you know, these 6 subintervals, right? So 1, 2, 3, 4, 5, 6. It's just those 3 trapezoids right there. So you could have said this is approximately, remember to get the area of each trapezoid, you could have said 1/2. First trapezoid is going to go from -3 to 0. So f of -3 plus f of 0, and then times the base, which was 3. And you could do this for each one. You know, the next one, 1/2, and now it goes from 0 to 3. So f of 0 plus f of 3, and then it still has a base of 3. Okay, and you need to do that 6 times, okay? And then essentially would be what we have right here. You know, the reason that we write it with the expansion is because you could factor the 1/2 out, which you could always do. Some of you guys even did that on your take-homes you submitted, which is fine. But if it's subintervals indicated by the data in the table, usually the heights aren't the same, your delta, whatever, but here it is. That's why you could factor all those 3's out. Then you'll see you're really just getting the f of -3 plus the f of 0. Okay, then another f of 0 plus an f of 3. Okay, so essentially it's the same thing. So I wanted to practice an expansion. You might not have an expansion on your AP. You might have subintervals of, you know, indicated by the data in the table. That's the best way to do it, because even if they're subintervals of equal length, that'll still work out, okay? You have that written. I'm just going to white this out right here. And I'll even do this because I want you to think that's the right answer now, because obviously it's missing stuff. But I want to make sure we got the room we need for part E, which is part E, right? E. This is a question of my own concoction. Let h of x, a wild new function appears, be a function such that h prime of x is equal to f of x, and h of 0 is equal to 10. Anish condish. Approximate h of 12 using a right Riemann sum with 4 subintervals of equal length. You don't normally see this. It showed up in one of the practice problems for the BC calculus exam this year, but it's a piece of BC that you could do. So I just want to do one like this real quick. If you want to know h of 12, you want to approximate it. Remember, if you want to approximate a function at an x value, you just need the function evaluated at some other x value and the rate at which the function changes to do so. You know, h of 12 would be equal to, this is the fundamental theorem, h of 0 plus, what the heck was the change in h from x equals 0 to x equals 12? And to get the change in h, you integrate the rate at which x changes, okay? And, you know, we've done this plenty of times, okay? But now they want you to approximate this. So why are we approximating it? Well, h of 0 we know is 10, but this integral expression right here, we can't get what the exact value is unless we knew what h prime of x was. Now, h prime of x, they did tell us is f of x, but we don't have the algebraic rule for f of x, so we can't integrate this the way that we normally do it, okay? So we'll actually approximate this using that right Riemann sum with 4 subintervals of equal length. Okay, so it's not subintervals indicated by the data in a table or something like that. Subintervals of equal length, so that's going to be 10 plus. You know, remember, what's really going on here is you need your delta x. What did I say here? Delta t, you could use the delta t. Here I have it abstract, so it's set up a delta x. There's nothing wrong with that. It's a dummy variable type of thing. Don't freak out about that. But really, b minus a over n, so 12 minus 0 over the number of subintervals, which is 4 here. So we can see we get delta x equal to 3, just like delta t was equal to 3 in the last problem. When you do a right Riemann sum expansion, you always, or any Riemann sum expansion, you always start with your delta x first, okay? And then you just worry about 4 heights, right? 4 rectangles, you need 4 heights. They're going to be f ofs. It's been a little while since we did this. Wanted to make sure we got to practice in this the day before the AP. That first rectangle starts at the lower bound, and it ends 1 delta x later. Since it's a right Riemann sum, I want to use f of 3 to determine the height. If it was a left Riemann sum, I'd say f of 0. Then you could just go here and add delta x to the argument each time, so f of 6 plus f of 9. Right now, no, there's only 3 heights. I need f of 12, because that right there is going to get me what that final height is equal to. You know, right Riemann sum will always end at f of the upper bound. It'll always start f of 1 delta x to the right of the lower bound. Not that we think about that a lot. So it's cool because it's a fundamental theorem of integral calculus problem, and then you have to use a Riemann sum to approximate the definite integral piece. We've seen ones here where you have to do it, you know, algebraically by just integrating, or even graphically, right? If it's like semicircles and line segments, stuff like that. This is the third way you could see that, when it's kind of represented tably, even though this is a graph, but we have to use those values because you can't calculate those, you know, values easily here. By the way, don't leave it in function notation. We know f of 3 is 1, plus f of 6, which is 3, plus f of 9, which is 1, plus f of 12, which is 0. And that right there is the approximation you're looking for, okay? And look, last thing we're doing, all right? So I hope you look at this on Monday, hopefully not too late, okay? You have some practice problems to finish up on here, and you got that 2020 problem, you know, the 2 problems, the practice AP I posted. Please take a look at that. You know, if you're cut for time, then try to actually take a look at that, you know, instead of this, I guess, doing the rest of these problems. I'm also thinking right now, Monday, geez, do you have an AP on Monday? Maybe it's Gov or something like that. So what I'll do is I'm actually going to post all this stuff. This is Friday right now. I'll post this over the weekend. Probably on Saturday, I'll post your Monday lesson. That way, if you know you're kind of focusing on taking an AP Monday and stuff like that, you can get this stuff done a little bit earlier. Maybe wake up Tuesday early, you know, and get some calculus stuff in your brain. Look, figure it out, okay? That's what it is. As far as when you get older, when you're in college, you're going to have to come up with all this stuff on your own, this time management. It's a good time to start thinking about that now. Look, you could do well on this thing. Remember, when you take it, one of the ways they're trying to discourage cheating is they're planning on giving a bunch of extra parts on problems that they don't even think people are going to get to. Okay, so please look at each piece separately. If you could do it, go on with your bad self. If you could do pieces of it, do that, get some points. If you see a problem you don't know how to do, skip it. I don't know if you skip, I don't care if you skip 3 parts in a row, okay? Don't start feeling anxious. Who knows? Part F might be something that's really easy to do, okay? So they're trying to mess with you, okay? Don't get into a head game with the squirrels. Just make sure you're prepared to upload answers. Then just take a nice little breath, okay? If you need to, take a breath, you know, take a breath for 4 seconds, hold it for 8 seconds, and then let it out for 7 seconds. Let's try. That's supposed to calm you down right there. And just focus on these problems. Don't freak out, okay? You could freak after the exam, you go in your room, you cry, you stay in your room, you remind, you know, text me, Berto, I hate you, da-da-da. You do any of that, but during this exam, you're going to be cool, confident. You are the man, you are the woman, okay? You know your stuff. If you don't know your stuff, fake that you know it. Pretend that you know it. Trick your brain into it. You'd be surprised. There might be a lot of stuff that you can do on instinct. Do all the little parts of the problems that you know how to do because you've seen them before. Then take the time saved and go back and then try to earn points on the other parts of problems if you can. Remember, 5 minutes, okay, you know, before the end of the problem, they take the next problem. There's a little timer on the bottom. It'll tell you to submit. Don't mess around and be like, hey, you know what, I'm going to extra 3 minutes, and then I'll submit with 2 minutes. I'd be very careful with stuff like that. Even if your plan is set up, who knows, with all these things being submitted to the College Board at the same time, if there are going to be issues and errors and stuff like that. So look, have your plan, be cool and confident, execute your plan. You're going to be good to go. Okay, you text me later on with Remind. You let me know how you thought the AP was. Don't tell me about any specific parts of the AP exam because you're not allowed to talk about that. Probably until 48 hours after. They'll have you, you know, sign something virtually. But I will later this year. Get back your free response problems. Look at this. I'm going to be able to see your answers. Don't embarrass yourself. Don't embarrass me. Put in effort. You'll feel so satisfied. And then we could chill for pretty much the rest of the year. We'll post some problem solutions and stuff like that. But just worry about that after the AP exam. Good luck. Love you all. You're gonna do great. Berto signing off. Adios.